You know, your skin is talking to you all the time. That little itch, a sudden flush of warmth, the feeling of a breeze, it's just this constant flood of information. But sometimes that message is actually a warning. It's a tiny, tiny signal of a much bigger problem that's hidden deep inside its microscopic world. So let's play detective. Let's dive in and decode some of these secret messages.
But just imagine for a second, what if that line of communication just broke down? What if those delicate little structures that are responsible for feeling or, for just holding your skin together, what if they started to fail? We're about to investigate 2 real-life medical cases where exactly that happened. And we'll see how solving these microscopic mysteries is absolutely key to understanding our own health.
Okay, so our first case file, it opens with what sounds like a pretty simple complaint, right? But it's actually a classic puzzle, and it points to a very specific microscopic culprit. So let's meet the patient and get to the bottom of this. So here it is, the core of the problem, a tingling and numbness that just won't quit. And get this, it's not his whole arm, not even his whole hand. It's laser focused on a single finger. That right there, that localization, that's our first major clue.
Okay, let's lay out the evidence. We've got a 40-year-old man. The problem is isolated to his left index finger. He's lost the ability to feel a light touch, and he's having trouble with what's called 2-point discrimination. That's, telling if he's being touched in one spot or too close together. But, and this is absolutely crucial, he can still feel pain and temperature perfectly fine. That tells us we're not looking for some kind of widespread nerve damage. Nope, we are hunting for a very, very specialized kind of sensor.
So, let's line up our sensory suspects. In our skin, we have all these different receptors, and each one has a very specific job. You've got your free nerve endings. They handle the basics, like pain and temperature. Deeper down, you have Pacinian and Ruffini corpuscles, which deal with things like deep pressure and skin stretch. And then, you have Meissner corpuscles. Their whole job is light touch and picking up fine details. So, based on the clues, which one do you think is our culprit?
All right, if you put your money on the sensor that handles light touch and fine details, you just cracked the case. The evidence is overwhelming, and it points to one structure and one structure only.
And the culprit is the Meissner corpuscle. These incredible little sensors are packed into the tips of our fingers. They're the reason we can read Braille or feel the subtle texture of silk. They are specifically built for the exact sensations our patient lost. It's a perfect match.
And this really shows why location is everything in this mystery. See, the Meissner corpuscles are located way up in the dermal papillae, which are these little projections that stick up right under the surface of the skin. It's the perfect spot for picking up fine details. A deeper sensor, something like a Pacinian corpuscle, well, that's built for feeling deep pressure and vibrations. If that was the problem, his symptoms would be totally different. The specific loss of light touch pointed the finger directly at the Meissner corpuscle. Case closed.
All right, let's move on to our next case. And I'll warn you, this one is much more dramatic, much more urgent. This time the problem isn't about sensation. It's about the very structure that holds our skin together. This is a story about the very glue of life.
Our second patient is just a 6-month-old baby, and the symptom is just heartbreaking. Severe, painful blistering all over their body. The skin, which is supposed to be our #1 barrier against the outside world, is literally failing.
When they took a biopsy, the clues they found were incredibly precise. The blisters were forming within the epidermis, that's the topmost layer of skin. This means the skin cells themselves were separating from each other. The root cause? A failure of cell-to-cell adhesion. And then the genetic tests found it, a mutation affecting proteins called desmogleins, which are a major part of that glue holding skin cells together. This, right here, is our smoking gun.
So just like before, let's look at our lineup of suspect. We're talking about the different junctions that hold our skin cells together. You've got hemidesmosomes, which are like anchors, holding the whole layer of skin down. Tight junctions, which are like the caulk between tiles, creating a waterproof seal. Gap junctions are like secret tunnels, letting cells talk to each other directly. And then there are desmosomes. Think of these as powerful, microscopic rivets, physically binding cells to each other so they can resist stress. So, given the clues, which one of these do you think failed?
That genetic clue, the problem with desmoglein, points us straight to the culprit. The problem lies with that cellular rivet, the very thing that's supposed to give our skin its incredible strength.
It's the desmosome. Desmogleins are a critical piece of these structures, and when they're faulty, well, The rivets just pop. The skin cells can no longer hang on to each other, and with even the slightest friction or stress, they just pull apart, creating those agonizing blisters.
You know, there's a specific medical term for this whole process: acanthosis. It's a really key idea here. It literally means the breakdown of the connections between skin cells. This isn't just some side effect. It's the core mechanism of the disease. The failure of those desmosomes directly causes acanthosis, which in turn causes those intraepidermal blisters they saw in the biopsy.
And again, let's just quickly look at why the other suspects were innocent. If, say, the hemidesmosum had failed, the anchor, then the entire top layer of skin would lift off from the layer below it. That creates what's called a subepidermal blister. But the biopsy was crystal clear. It was an intraepidermal blister. The cells were separating from each other. That distinction makes all the difference in the world for getting the right diagnosis. It proves without a doubt that the failure was the desmosome, the rivet between the cells. So there we have it. Two really different cases, right? A tingling finger and incredibly fragile skin. But when you get right down to it, they tell the exact same story. The biggest problems often start with the absolute smallest structures.
So what's the big takeaway here? Well, in our first mystery, a problem with one tiny little sensor, the Meissner corpuscle, fundamentally changed how that patient experienced the world. In the second, a defect in a single cellular rivet, the desmosome, put the body's most important shield at risk. It just makes it so clear that these invisible parts are the very foundation of our health. And understanding them at this level of detail, well, that's the first step to creating targeted treatments that can actually fix the problem at its source.
It really makes you think, doesn't it? Our skin is this whole universe of complex, interconnected parts, and every single one is telling a story. It kind of leaves us with one final question. What other microscopic mysteries, what other secrets are just waiting to be solved right under our own skin? If only we know how to look and how to listen.